Okay. Right. Now let's get started. I still see only 10 people joining the class point. If you haven't joined the class point, please do so. Because in the next slide, I have a short question for you. So when you heard the word socket, what do you have in mind? So please write it down. So what is a socket? When you get socket, okay. What's that? Okay, we still have 19 participants in the class point. On Zoom, we have 27. So I expect some more of you joining in. Okay, I'm gonna close the session. Chop-chopan. Yes, I like that. Chop-chopan. And then client server jagat says stop contact. And then Alam Baka, is that your real name? To stick my charger. Titik akhir komunikasi dalam jaringan. Tahu penghubung. Okay, so I like the term chop-chopan or stop contact. I mean, that's pretty much defines what a socket is, really. Okay, now let's move on. So yeah, so chop-chopan would be the closest analogy that we have with the socket in terms of computer network programming. Because with chop-chopan or the what you call socket, you can get something out of it, and then you can also put something inside it. So you can plug the you can plug the cable into the socket, and then you get some electricity out of it. And basically, you can communicate with the electricity by using that socket. So the principle is pretty much the same with the one in computer network. So in computer network, a socket can be a software object, or let's say just a variable that allows us to connect our applications to the network protocol. So with socket, it kind of help us to build an application that can send messages or receive messages from the network or to the network, right? So what if we don't have a socket? So the thing is, if we don't have a socket, we will have to do everything on our own. So if we go back to the previous meetings where we talk about TCP, UDP, and IP, imagine you have, when you want to send a message, you let's say you want to create a browser that sends an HTTP request to the Google web server, let's say. So what would you have to do without a socket is, first you need to craft the message, the HTTP message, and then you need to split those messages into multiple segments. And then for each segment, you have to assign the port, the source as and destination ports manually, and then you will have to assign some informations in regards to TCP or UDP, and then for each segment, you have to wrap it into a network packet, and then you have to assign, or you have to set the IP address, the IP address is the network, the source and destination IP address. You have to set some time to live. You have to set lots of informations what that is usually contained in a IP packet. And then you will have to do lots of stuff basically to send the message through the network. But with socket, what you have to do is just to craft the message and then give that message into the socket, and then let the socket communicate with the operating system so that you can send that message over the network. So in a short word, in a short sentence, a socket helps you to send the message over the network. So you don't have to worry about creating your segments, creating the IP packets individually, and so on. And another term or another definition for a socket is it can be a connection between two hosts. I think one of you said that in the previous slide. So let's imagine another analogy with telephone lines. So the socket itself is the telephone. Do you know what this symbol means? Just in case. Are you familiar with this symbol? Do you know what this is? Hello? Anyone? Hello? Okay, we call it landline, but yeah, it's a phone. It's a phone. I'm not sure if you've seen this one, but it's actually an old phone. It's an old type of landline phone. Okay, but let's say this is a phone. Okay, this is a phone, and a phone is connected to the telephone network. And then if you want to call your friend, you have to pick up the phone, and then you need to dial some number, and then you will need to wait for your friend to answer the phone. When they answer the phone, you can both start talking. So a socket is pretty much like a telephone. So in order for you to be able to send messages to the other computer in the network,
you have to tell the socket, hey socket, I need to call this number, or I need to call this IP address and port. And then the socket will do the rest. It will try to contact the server or craft the message, something like that. And then once the connection is established, you can use that socket to send the message. It's like when you speak to your phone, your voice will be transferred over the network, over the telephone network, and then it will be delivered to your friend, and then so that your friend can hear you. And with socket, it's pretty much the same. So when you want to send a message, you give the socket a message, and then it will do what it needs to do to deliver the message. So there are some basic operations that a socket can do. We have 1, 2, 3, 4, 5, 6, 7. So we have 7 operations where a socket can do. We can tell the socket to connect to a remote machine. So it's like when you use your phone to dial a number. And then you can use the socket to send and receive data. So it's like when you use a phone to speak and to hear what your friend's saying. And then you can also tell a socket to close the connections. So it's like hanging up the phone. So when you press the close button on your phone when you want to end the call. So I think this one is pretty much simple. The first 4 operations. And then you can also use a socket to bind to a port. I don't think we have something similar with the normal telephone, but binding to a port means we tell the socket to contact the operating system that it wants to book a port or to make a reservation for a port. So it's like when you're coming to a restaurant and then you say to the, or if you want to have a dinner in a restaurant and then you call the staff, hey, I want to make a booking for 1 table at 9:50, that's it. So at that point, you bind a table for you so that anyone else cannot use that table to eat. And the same principle applies to socket. So when you bind a port, you kind of tell the operating system, hey, operating system, I want to use this port. I don't want any other
get using that particular port number. So we will not be using this operations for the time being, but because usually for this operation, it is only used by a socket in the server side. So for the client side, you will only normally use the first 4 operations. But for the server side, you will use the last 3. So you can tell the socket to find a port, to book a port, basically. And then you can also tell the port to listen for incoming data. So again, this is for the server side application. So you kind of tell the socket to start listening for any incoming client. It's kind of when you have a shop and then you want to open shop for customers. So you open the key, open the door, and let the customer comes in. So that's kind of how you listen for incoming data. And then you have this last operation, which is accept connection from remote machines on the bound port. So after you book a port number, you will tell the socket to listen for incoming data, and then you will need to tell the socket so that it can accept a connection. So imagine a socket is a shop, and then there are some people trying to get into the shop but they're not allowed to get in yet before you start accepting them. So they're queuing in front of your shop, and then you, as the staff, you tell the people, okay, the first person can come in. So that's the process of accepting. Start accepting connection from a remote machine. Okay, next machine.
Come in, you can talk to me. And then next machine, okay, you can come talk to me. Okay, you may forget about this soon because we will not be using this for at least 2 weeks, the last 3 operations. So today we're gonna be more focused on this part. So how we can create a socket that can connect to a remote machine, and then we tell that socket to send and receive some data. And then once we're done with it, we're gonna tell the socket to close the connection. So it's like, breaking up with the other party. Okay, I'm done with you. You're too good for me. I'm gonna end this connection. Okay. Any questions? Yep. Okay. Well, I've said this earlier, but this time I'm gonna be more specific in Java. So as you know, different languages may have different types or different term for socket, but in Java, there are 2 types of sockets. The first one is the server socket class. We will use this when we want to create a server application. So basically, we want to make an application that provides a service to clients. And then
type is the socket class. So the socket class is used by applications in both sides. So either you build a client-based application, or if you want to create a server application, both will use the socket class. But you don't need to worry about the server side first. You just need to bear in mind that there are 2 types of socket, the server socket and the socket class. And again, for today, we will be dealing mostly with the socket class. And how to use a socket to connect to remote machines? It's pretty simple. Oh, wait, hang on. I think we should be discussing about data input stream and buffer input stream. Just remember. Okay, maybe does anyone wants to share what's their finding about the difference between buffer input stream and data input stream? Again, I can give you some point to explain. Vishnu?
For the data and buffer, yes.
Yeah. Do you want to share a screen?
Yes, maybe.
Okay. Hang on, let me enable it first.
But I think my project is simple, but
That's okay.
okay.
We can start with something simple. Okay, go on, Vishnu.
Yes.
You can. Wait, I'm gonna stop sharing first.
Okay. It's still process. Okay. Is it shown in the?
Yes, I can see your screen.
Okay. Yes, sir. I try to build the main class and two kind of class. There is buffer input stream and data input stream. And I defer the implementation for this kind of code and try to call them using a static class that I create in the buffer input stream and data input stream implementation. Okay,
Okay.
maybe uh, I try to show about the buffer input stream. Yes. In the buffer input stream, there is the first time, of course, there is a file input stream to take the file, and then buffer input stream will take that file input stream to its buffer, and then uh, when we create another one of byte and uh, another one of variable byte and uh, array of bytes, and then we try to move the bytes that has been taken into the buffer input stream to the array of bytes, that is B. And then we try to what is, casting the bytes into the string type, and we place it into the temporary string. And after that, we could close the buffer input stream and file input stream, and then we get the temporary file, temporary string that has been created. This file is halo semua. When I try to uh, build the application, will show halo semua. And then
Okay.
for the data input stream, uh, it is actually almost the same, but the difference, uh, we just need to read, uh, we just need to move the this and read it into the array of bytes that has been created before. And after that, the array of bytes will be casted into the temporary string, and after that we could close data input stream and file input stream and shown the temporary string into all of the into the terminal. When we try to run this again, yes, actually it is almost the same output as before. Okay, maybe that's my program, sir.
Okay. Thank you, Vishnu, for showing your application. So, what can you say about the result?
I think there is no difference about all of them, but maybe the concept of what the buffer input stream and data input stream does into the array of bytes. I think yes, the behavior is different. Like for buffer input stream, uh, we get all of the bytes by using uh, by reading all of the bytes that has been stored into the buffer input stream. Uh, and buffer input stream, I think it will what we call menampung all of the bytes and then send it into the output if we read all of the bytes that has been stored into buffer input stream. But in the data input stream, I think the difference is the data input stream just read the column of bytes, the address of bytes, and then bind it into the what we call the output from data input stream. I think that is my answer.
Okay, exactly. So the results for both approaches are same. So as you can see, there's no difference. So the first point that I want to show you by using this exercise is because you have lots of ways to do one task, the same task. So you can use data input stream, you can use buffer input stream, the results are pretty much the same, or in this case, it's exactly the same. But the way to do it, the way you read the data, and the functions that you can call are different. So actually, I want to see, can if you go to your this source code, the data input stream code, can you see the list of methods in data input stream? So if you just type this.read and then that's good. So as you can see, if you type this.read, there are several options that you can use. You can use read boolean, you can use read byte, you can use read char, double, read float, read in, read long, and so on. And you can also use read UTF. And then you can also use read line. If you see that at the bottom, it's crossed because it's deprecated. We're not supposed to use it anymore, but it's still there. So with data input stream, you can do more what's called complicated stuff easier, because with buffer input stream, you treat all data as bytes, so you can only read them as bytes. With data input stream, if you know what you expect to read, let's say, okay, I'm gonna read an integer, so I'm gonna use read in or read short or read long, basically, because I know that the next item in the source of data will be an integer. But if you don't know what kind of data you're expecting, it's probably better to use the buffered input stream. So again, it's up to you to decide which one you want to use. It depends on your style of programming, and it depends on the case that you face. Okay, thank you, Vishnu, for sharing this. I'm gonna share my screen again. Where's my Zoom? Ryan, yeah, do you wanna?
Misi Pak, pengen nanya Pak.
Ya.
Saya nyoba juga nih yang kayak Wisnu, terus yang buffered input stream. Cuma metode yang tadi kan Wisnu pakai itu kan namanya read all bytes ya, iya nggak sih?
Ya, betul.
Cuma di saya nggak ada Pak. Jadi saya nyoba pakai cara lain. Nah itu kenapa nggak ada bisa gitu?
Kamu pakai Java versi berapa?
Ngelihatnya di mana Pak ya?
Kamu di apa ya? Saya nggak tahu kalau Windows gimana ya. Di apa namanya? Di daftar program yang terinstall itu apa sih biasanya di Windows? Coba kamu di add or remove programs.
Java SE 1.8 ini Pak, ini bukan.
Ya, Java 8 ya.
Java SE 1.8.
Java, saya biasanya Java SE Development Kit 17.0.2 itu di punya saya. Wisnu pakai yang mana?
Berarti maksudnya Java saya kayak ketinggalan versi gitu atau gimana Pak?
Ya, kurang lebih begitu. Karena seingat saya memang read all bytes itu tidak ada. Terakhir saya ngajar ini 5 tahun yang lalu. 5 tahun yang lalu read all bytes itu belum ada di buffer input stream.
Nah, berarti saya si versi lama ya.
Mungkin masih pakai versi lama, tapi nggak masalah. Kamu bisa update atau mungkin kamu bisa menyesuaikan nanti. Oke.
Ya, baik Pak. Terima kasih Pak. Terminal Java C main version. Coba.
Ya, itu buat ngecek Java
compiler.
compiler.
Wisnu. Di terminal itu di CMD maksudnya?
Ya, CMD.
Java C.
Ini kalau di tempat saya kayak gini.
Java C 11.0.8.
Nah, 11 itu lumayan lama itu.
Lama ya berarti ya. Oke, Pak. Makasih.
Yang terbaru kalau nggak salah sekitar 17-18.
Iya, baik Pak. Terima kasih. Wisnu juga terima kasih Wisnu.
Oke. Bisa ya?
Loh, kok bisa? Aduh.
Sama pastikan juga ini Java doc-nya. Java doc-nya yang baru nggak? Karena kalau Java doc-nya nggak sama, waktu kalian autocomplete, itu yang keluar definisi dari fungsi yang lama, bukan fungsi yang baru. Jadi pastikan Java doc-nya sama. Ini kan saya pakai
Oh, iya.
Java 17. Nah, Java doc saya juga harus yang versi 17, jangan yang versi lama.
Kira-kira Pak, kalau saya nggak ngupdate Java saya ada masalah nggak ke depannya Pak?
Enggak sih, karena
Enggak ya?
kita pakai fungsi-fungsi dasar. Jadi kamu pakai misalkan nggak ada read all bytes, kamu pakai read biasa juga tetap
Iya,
sama.
saya
Nggak
mau
ada.
kayak gitu-gitu. Apa?
Atau pakai yang read aja tapi yang parameternya ada bytes-nya di dalamnya, nah itu juga bisa, sama aja sih.
Oke ya, pakai yang itu bener. Sama, iya bener. Ya udah, makasih Pak ya.
Oke, ada pertanyaan lagi? Oke, kalau tidak ada, I'm gonna explain how we use a socket first, and I'm gonna show you later how it works. So basically, there are 4 steps that you need to do. There are 4 basic steps that you need to do to create an application that connects to another application on a remote machine and then exchange messages with them. So the first thing that you need to do is create a new object. With Java, we call it an object, not a variable. So we create a new object socket, and then there are various constructors for doing it, but usually I use these constructor where you just have to mention the name of the host or the IP address of the host, and then you mention the port number. And then in this case, I'm gonna create a new socket object that will connect to Monta server, and then to port 80. This is the port for HTTP. And then after you created the socket object, you need to obtain the input and output stream. So before you start sending and receiving data, you need to get the input and output streams. Again, because the socket itself, it doesn't actually send or receive the message. But inside the socket object, we have streams. And that's why I asked you to experiment with streams earlier with files, because the basic concepts are the same. So first, you need to obtain the input and output stream from the socket object by doing this. So basically, you just need to call the get input stream method from the socket object. I think I made a typo here. Should be socket.get input stream and then socket.get output stream. Okay. And then I change this input and output stream with buffered input and buffered output stream, because why not? Well, mainly because it makes things easier, because I have more options with the read and write methods. You can also change this with data input stream if you want. We can experiment with that later. But for now, let's say we use buffered input stream and buffered output stream. So once we get the input and output stream, we can start exchanging messages. So we can send the message using the write method, and then we can receive the message using the read method or any variation of read method. Once you're done with exchanging messages, you can close the socket, because what we're using now is a TCP socket. So we need to start a connection or a relation with a good manner, and then we also need to end it with a good manner as well. So why we need to do that? Because I know that computer doesn't have feelings, but in this case of TCP, when you create a socket, the application will allocate some place in a memory, and then when you close that, when you close the socket, it frees the memories. Basically, you can have some additional space in the memory when you close the socket. But if you don't close the socket, you will have some place in the memory that you don't use, but it's still there. It's just, you know, wasting some space. Okay. Now let's do some demonstrations. I'm gonna show you how we do this. Just bear with me. Okay, can you see the net pins now?
Yes, sir.
Okay, cool. Okay, I'm just gonna use the main functions. So I'm gonna just repeat the thing that I just explained. First, we need to create a socket object. As you can see, there are lots of options for the constructors, and then just gonna use the one that accepts a string and an integer. So I'm gonna type monta.pf.ifs.ac.id. You can also follow this at your home. As you can see, there are some red lines, jagged red lines. Just gonna do enter surround statement with try catch. There you go. Okay, so that's the first step. We need to create a new socket object. We did this, and then step 2 is we need to obtain the input and output stream. Okay, I'm just gonna use buffered input stream. If you want to try with the data input stream, feel free to do so. First input stream, and then accept one parameter that we get from socket.get input stream. Then we also create a buffered output stream. And then we just pass the socket.get output stream to the constructor. So now we have both input and output stream. So we're supposed to exchange the message here. And then step 4, the connection. Okay, we're almost done. We're almost done. Yeah, I'll give you some time if you want to follow this. There you go. Okay. So now we need to exchange message, right? Need your help here. Do you want to receive a message first, or do you want to send a message first? Okay, let's do some polling. Okay. So now open your ClassPoint app. I'm gonna do some voting, a democratic one. If you pick one, you will send a message first. If you pick two, you will receive a message first. Because at this stage, you're supposed to be connected to the remote machine, but you don't exchange anything. You haven't sent or received anything from the remote machines. So which one do you want to do? Do you want to send it first, send the message first, or do you want to receive the message first? Okay, let's see some responses. Okay, 8 people voted for sending. Okay, I think the sending part wins the vote. Okay, now we're gonna send a message first. So how do I send the message? So if I want to send a message, which one do I use? The input stream or the output stream?
Output stream, sir.
Yes, correct. So we're gonna use the output stream to send the message. How do we send the message? It's just gonna type the message. Okay. We don't have many options for the write method, so I'm just gonna send a series of bytes. So I'm just gonna do this. Again, this is always the first thing that we need to send. Hello world. I'm just gonna add some stuff here. Get bytes. There you go. So we just send a message, and I guess we're expecting some response, right? So we're gonna just read some things. I'm just gonna use read all bytes. Gonna save it in a byte array. Okay, and then I'm just gonna print this. String. Okay, just gonna print the bytes as a string. Okay, now let's see what happens. TikTok, TikTok. Yeah, I'm just gonna go for a bit while waiting for this code to run. Okay, let's see. So as you can see, we don't see anything here. So we don't see any response from the server. Let's check. Just gonna debug this one. Maybe let's do the old style debugging. This is not the proper one, but I think it's better for us if you want to learn about this. One, two, three, four. Okay, let's see where the line stops. Okay, line 1 and line 2 printed almost immediately. So that means we send the data to the server and we're expecting some response, right? Then, okay, it takes a while to read the response if there's any from the server. Okay, while waiting, I'm going to talk about this method a bit. As you can see the definitions, this method reads all bytes from the input stream, and then this method blocks until all remaining bytes have been read and end of stream is detected. So once the connection once we start reading, when the connection is still open, this function will keep blocking. It will keep blocking until the connection is closed, either by us or by the remote machines. In this case, we can safely guess that it's the remote machine that closed the connection. So we didn't receive any data because they didn't send any message and they closed the connections. Okay, I'm gonna change the write method a bit. So instead of sending just hello world, I'm just gonna add these characters, the new line characters. And then let's run it again. Okay, can anyone guess what's wrong with our code, with my code?
I think because the write it is not in HTTP format, which was the standard
Yes, that's
standard for changing message between internet.
okay. So basically, yes, we didn't follow the HTTP message format, and what we expect to see is actually an error message because we don't follow the convention. But in here, we didn't receive anything, even though I put the double new line. So remember, when you write something, when you go to the toilet, what you need to do after you're done with your business in the toilet? You need to flush. Now let's see what's the difference does it make, or does it make any difference at all? Oh, now we have something different, right? The thing is here with buffered input stream, because we write something into the buffer, we only wrote it again into the buffer. We didn't actually send it through the network. So when we call the flush method, it will force the buffer to be sent to the network, and then it is received by the application on the server side, and then it will respond. It responded according to the request that we made, because we just sent a hello world and then followed by /r/n twice. It will give us a path request. So it's kind of tell us what are you talking about, client? I don't understand, because we didn't follow the convention. But basically, this is how we send a message to a server, and then this is how we read the message from the server. We can also change this instead of read all bytes, because read all bytes relies on the connections being closed, because if the connection is not closed, you will get stuck on this line. So usually this is not a safe method to use. So usually what I do is something like this. So instead of read all bytes, I'm gonna read n bytes. I'm gonna read like maybe 10 bytes each. That's the size of the buffer, be 100. Again, and then let's check with the method definitions. So it reads up to a set number of bytes from the input streams. Let's see the written definitions.
Excuse me, sir.
Yes.
Could you increase the font size?
Oh, okay, sorry. How do I font size? Hang on. Nope, not this one. Options. Font and colors. Let's do 15. Okay, what about this?
Yes, sir. It's enough, I think.
Okay, if it's not big enough, just let me know. Okay, where was I? Oh, okay. So can just cover size. Let's change this to cover size, and then if length smaller than buffer size. So that's when we know that the end of stream is reached. Again, in this case, the end of stream is only reached when one of the parties close the connection. Okay, so plus uh, okay, so yeah, rest. We created an empty string, and then oh wait, I forgot to do this. Otherwise, it would be an infinite loop. Okay, so first we do this. We read some bytes from the stream, and if the length of the bytes read is less than the length of our buffer size, that means that's when we know that we reach the end of stream, or we reach the end of file. It's slightly more complicated than the previous method where you just have to type read all bytes, but with this one you can have more control over your data. We'll see other variations later on, but let's see the result first. Okay, different. Did I make a mistake? Okay, so we expect to see the same result. Buffer size under is length. Oh, logic fault. There you go. Okay, so now we have this one. It's pretty much the same result, but we have more control over our code. Okay, any questions so far about this code? Oh wait, I think we made a mistake. No, this doesn't print the correct. We can use this one. Read. It's gonna fill in that thing. Okay. We have this and uh, oh, we actually did. We have to do it correctly. Okay, there's a mistake on that. But yeah, you can see that there are several ways that we can do to read the message. Okay, if you don't have any questions, I'm gonna go back to the slide again. We'll come back to the code later.
Okay, sir. I want to ask.
Yeah,
What's
go ahead,
the
please.
difference between before
The what?
like the code? I don't know what's the difference between the
Oh,
last code.
with this one.
Yes.
No, there's no difference actually. I just called it different methods, but the results are actually the same. I just made a mistake with thinking that this is the incorrect. This is I thought it was an incorrect output, but actually this is the correct output. This is what we expected to see. So instead of you can use read n bytes, or you can use piece.read like this. So with piece.read, you put the buffer inside the parameter. With read n bytes, you use the buffer as the return value. So you set the return value of the read n bytes into the buffer. Basically, just swap the variable of the object, really. So there's no difference. There's no fundamentally different way to do it. Okay, anything else? Okay, so otherwise, I'm gonna explain a bit about some basic concepts in the socket programming. So first, we're gonna have to get used to the exceptions, because there are some exceptions that that may appear when you create the applications or when you run the application. The most common one obviously is the IO exception. So this usually happens when maybe the remote machines close the connections, or the remote machine just turned off because of some electricity problem, something like that. And then because this is the umbrella or the like the big term for the common exceptions in the case of socket programming, you have more specific exceptions that are derived from these exceptions. So we have IO exception, then we have socket exception. So that means it's an exception that's specific to the socket itself. And then we also have bind exceptions, connect exception, and no route to host exception. There may be some other exceptions, but these are the most common ones. So bind exceptions occurs when as the name implies, when there's a problem when binding a port to your applications, but we don't use that now. Connect exceptions occurs when you want to connect to a remote machine and then it is refused, or maybe there's another problem during the connection phase. And then no route to host exceptions occurs when, as the name implies, there is no route to host. So that means there's a connection problem with your computer. So you can be specific by catching each of these exceptions, or you can be generic by using just IO exception and then print what the error message is. So if you look at my code, I just catch the IO exception and then print any error message that I might have. And then there's another class that you may need to know. There's something called INET socket address class or internet socket address class. Basically, this class is just an additional class. It's not really important, but it might be useful for you if you want to store the information of the IP address and the port of the other machines that you want to connect. So even though the socket is closed, you can get the IP address and the port information. So in here, I can store the host name or the IP address and the port number into this variable. And then when I create the socket, instead of mentioning this host name and the port number, I just call the sa.getAddress or sa.getPort. Okay, well, it's pretty much the same as it was. And yeah, now we're back to HTTP again. Because in the beginning, we didn't, as we said that before, Axel, I think. Yeah, because we didn't follow the HTTP convention when sending the message, so we got this error 400 path request. So that means the server doesn't understand what we were telling them. So they didn't understand hello world. So they don't know what it means, right? Because we didn't follow. Now let's follow the correct way by first learning about HTTP. So before we get deeper into HTTP, there's one concept that I need you to know. It's about the uniform resource identifier. What's this? It is basically a string, a simple string that is used to identify resources on the internet. So if you want to know where your file is located or where your website is located, a specific page of your website is located, you will need to use the uniform resource identifier. if you haven't heard of this before, you may have seen the examples. So this is an example of URI. I call it URI, Uniform Resource Identifier. And URI always consists of two parts. So the first part is the URL, or Uniform Resource Locator. So that's like the contains information about where the resource is located and what kind of protocol we should be using. And then second part is the Uniform Resource Name, or the URN. And then as the name implies, this is the name of your resource. So this is like this specific page that you want to access, specific file, specific folder that you want to access. Again, this is some review of HTTP. We have, HTTP Hypertext Transfer Protocol. I'm sure you're quite familiar with it. And if you want to see the technical specification of HTTP, you can have a look at RFC 2616. That's the standard written for HTTP version 1.1. There was HTTP 1.0, but there's not much difference. We'll be using mostly HTTP 1.1. And just so you know, recently we also have HTTP 2.0. It's a massive difference between, there's a massive difference between HTTP 2.0 and HTTP 1.1. One of the big difference is that it is no longer a text-based protocol in HTTP 2.0. That's why in this class, we will still be using HTTP 1.1. And anyway, on the internet, most websites, I believe they still use HTTP 1.1. Okay, next is how HTTP works. So basically, when you have a browser that wants to access a specific web page on the web server, it will send an HTTP request, and then the server will reply with a HTTP response. And for each HTTP request, we have two parts. The first part is the request line. That's like the first line of the HTTP request. And then the rest of it are the HTTP headers. Some HTTP requests may contain some data. So like when you are logging in, you send your username and password inside the HTTP request body. We will talk about that later. And as for the HTTP response, we have the status line, and then some HTTP response headers, and then we have the content, or if it's an image, that's the content of the image. If it's an HTML file, that's the content of the HTML file. If it's a movie, it is the byte stream of the movie, and so on. So this is an example of an HTTP request header. So when your browser wants to access a specific website, it will send these lines, something like this, basically. So the first two lines are pretty much standard. So you always have the request method. This one is get, and then you have the URN, and then you have the HTTP version, and then lastly you have the host headers. So this specifies the specific website that you want to access, because sometimes in a web server they can host multiple websites under different domain names. Okay, let me turn on my virtual machine first. Okay, maybe any questions before while waiting for my virtual machine to show up. shoot up. Okay, are you seeing the virtual machine now?
Yes, sir.
Okay, I'm just gonna demonstrate how to send an HTTP message with Telnet. So I'm just gonna use Monta again. It's gonna send hello world just like we did with our code. We got a similar response. Hello world HTTP 1.1 400 path request. So this is the HTTP request that we did, which is wrong. And this is the response we got from the server. Now let's send a proper HTTP message. So I'm gonna use CRM. Yeah. Okay, let's do the proper. Okay, let's do the proper request first. So here, as you can see, I just requested a file or a folder, basically, from a specific website, and then I mentioned the host monta.fs as a ID, and then I get a response from the server. Right? What else we have on the same server? I don't know. Or maybe let's try with different website. This one. Okay, so this time I tried to connect to its.ac.id on port 80. I mean, I sent an HTTP request without the host headers. And if you notice, it tries to redirect me to another website, which is called info.its.ac. Now, let's do something similar. But this time I put the host header. Okay. Can you see the difference now? The response between this one. This is when I mentioned the host headers, and this one when I didn't mention the host headers. What's the difference? Anyone? Okay, I'll make it a bit smaller so you can see the whole machine. What's the difference between this one and this one?
So I think the connection is keep alive if you mention the first. I see the context.
Okay,
The content.
that's one difference. There's another difference.
I think it is the response location, sir.
Yeah, exactly. So I'm gonna explain both of these. So when you receive a response header 301, so that means you have to, or the browser is told to access another web page. And the other web page that the browser needs to access is this one. But if you can see here, there's a difference between when we mention the host header, it redirects us to info.its as a ID. But when we mention the host header to specify that we want to access the itsac.id, then it will try to redirect us to www.its.ic.id. So that means we have at least two websites on the same server. One is info.its.id, the other one is www.its.id. Okay, and the other difference is the connection keep live. I don't know if you noticed that, but when the connection says, then the connection header says close, once we receive the end of the message, the connection is closed immediately. But when we use the connection keep alive, the connection, as the name implies, it's kept alive. So that means it's not closed after the message has been sent. So that's why that's the difference between keep live and close. So when the connection is closed, when the connection header is closed, the server will close the connection once they finish sending a message. But if the connection is kept live, well, the connection is kept live. Okay, so that's an example of sending an HTTP request. Just go back to the slide again. So we have lots of headers here. We have user agent. This is the browser code, so that the server knows what kind of browser we are using to access them. And then we have some other request headers here. And it's an example of the response header. It's pretty much the same, just like we had earlier. So this is the first is the protocol version, HTTP 1.1 or 1.0. And then the most important part is actually the status code. So we always expect to have 200 OK. So that means, okay, the server kind of saying, okay, I accept your request and this is the resource that you wanted. And the rest are the HTTP headers with the format of name and then name and value separated by a column. So you have date, server, connection close, pragma expires, last modified, content encoding, and so on. Each web server application may have different HTTP headers, but we always know that each pair of name and value is each line is separated by so each header, each HTTP header is separated by a new line. So we have here, this is one HTTP header, this is the second HTTP header. They are separated by a new line. Okay, now let's do some brain gymnastics. We just use an HTTP request method with telnet before. Do you know what other HTTP request methods? Wait, sorry. Okay, let's see. 9 people. We have put, get, post, delete, head. Okay, we have a lot actually. Yeah. So we have quite a lot of HTTP request methods, but the most commonly used HTTP request methods are get and post. So we use get usually to request for a resource on the web server, and typically we don't send any data. Although we can still send some data through the query string, but normally we don't use get if you want to send any data to the server. But instead we use post to send any data to the server. And there are some headers here that we need to use, but if you want specifically to use post, there are 2 headers that we need to use to kind of saying to the server, hey, I'm going to send you some data, and this is the type of data that I want to send, and the length of data that I want to send to you is this much. So that's why here we have the content type, and mostly it's always application-xwww form URL encoded. And then content length 43. So that means when we do a post request, we will have something called the request body. And the request body has the length of 43. Because why do we need to specify the length? Because normally HTTP request ends with a double new line. So backslash r, backslash n, backslash r, backslash n. Those are double new lines. And then the problem is with post, the thing that separates the request headers and the request body is also a double new line. So if you were the server, we would be very confused, because once we receive a double new line, we wouldn't know for sure whether we should read the next byte as part of the request, or we should stop reading and process the request. So that's why here we have the content length. So after the server, after reading double new lines, it will read the next 43 bytes and consider it as part of the request. So that's the request body. If we want to, how do we try this? Okay, let me show you this. Can you see the browser now? Okay, I'm just gonna do some login. I'm gonna log in and then gonna use the test password now. And then if I look at the request on the right side, it should be this one. How do I see the flow request? Um, how do I see the raw request? Okay, let's just assume this one. So this is the request headers, post, and blah, 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 and so on. And then as you can see, there is this content type and then content length. So this request headers ends with a double new line. And then after the double new line, we have this payload in form of a URL encoded string. So this is the message that is actually sent by my browser to the server. So this is the raw message. This is the 130 bytes sent by my browser. And some other request methods are head. It is usually used to check whether the file on the server has been updated since the last request or not. And we have options put and delete. You don't really need to worry about this because we don't really use it anymore. So that's the request method. And then we have the response status code. So in general, you see that the status code is always a digit with 3 numbers. If you want to see what it means, basically you just need to see the first digit, the first number in the first number basically. So if it's 1, that means, hold on, we rarely have this status code. If the first number is 2, that means our request is accepted, or it was a success. If the first number is 3, that means we have to go away, or the client needs to access another location, another resource, just like what we saw earlier when we got 301. That means we have to redirect to somewhere else. And then if we have the if the first digit of the response code is 4, that means the client messed up, or we might have sent a bad request or wrong request, or we may have requested a file that doesn't exist. So when you get 404 not found, so that means it's your mistake. It's the client mistake. But if we see the 5xx or 5 something, so that means the server messed up, or there was a problem with the server. So this is some commonly used HTTP response status code. We have 200, that means response okay, and then we have 206, that means it's a partial content. So if you use a download manager and then you want to download a file using multiple threads, you can use this one, the 206. Sorry, you will receive the 206 because it's a partial content, and then you need to combine those partial contents into a single file on your own. And when you receive 404, that means the file is not found. 401, that means unauthorized, usually when you're dealing with some basic authentications. 403 means forbidden. It's pretty much the same between 401 and 403, but with 403, the restriction is a bit different. When you have 301 and 302, that means you have, or your browser needs to access another resource. It might be on the same server, it might be on a different server. And you can have a look at the location headers. And then when you see 500, I believe you've seen this multiple times during the FRS. So when you receive 500, that means there's a problem with the website itself, with the server, with the code, either with the code or with the server. Okay, and these are some other important HTTP headers. So we have host, content type, content length, and last modified. So I think host is pretty much clear. It specifies the website that you want to access. Content type specifies the type of document or the type of request you're sending to the server, or maybe it's the type of the document you receive from the server. Content length is the length of the body, and then last modified usually specifies the date when the resource was last modified. Usually, if you want to check whether it has been updated or not, if it has been updated, you can just request a new one. Otherwise, you can just use the one in your cache. So in a browser, there's a cache. It's like a temporary storage where you send some files downloaded from the web server. So instead of keep downloading from the web server, you can just use the files in your local storage. So that speeds things up. Okay, now let's do some demonstration because we didn't do a proper HTTP request. Now, wait, what's time? Okay, we still have some time. Wait, where's the next? There you go. Okay, so we didn't send the proper message here. Now let's send a proper message. Let's do get HTTP 1.1 and then access bar access and host. Let's say monta.tf ID. Okay, now let's see the response we got from the server. Well, okay. We just received the message. Well, at least now we have the proper request and we received a proper response. We didn't receive any HTML file just because for Monta it's a bit different. So instead of using HTTP 300, 301 or 302 to redirect, it uses HTTP 200. That means it's okay. But if you see there's a header here called refresh, and then URL HTTP Monta http/index.php and so on. So this is the same concept basically to redirect the browser to the to the new website. Now let's try to access this URL. So instead of just using slash, let's modify the message we send to the server to something like this. I'm just gonna run this. Okay, well, now we have a proper HTML code, right? Now we have a proper HTML code. It's quite long. And you see there's some HTTP header in the beginning. Okay, well, any questions so far before I jump into another problem? Ada yang bingung? Gimana?
Not yet, sir.
Okay, so it's quite easy, right? Okay, so the hardest part, we haven't been to the hardest part of the socket programming. The hardest part of socket programming is actually not sending and receiving the message, but it's actually parsing those messages. So for now, we only have a bunch of bytes here, and then we just print them out. What if I want to collect just the status code? Right. So I just want to receive this line, basically, and then I want to obtain the status code. I just want to print the status code only. I don't want to print anything else. How would you do that?
I think we can use different input stream. There is axis readline function, and we split the first line and take the second index, the second element.
Yeah. Okay, let's try that. Let's try, instead of using buffered input stream, I'm gonna change this to data input stream. Okay, now again, we need to make some changes here. Just comment this out. let's try read line. So I'm just gonna read one line. And then I'll print the result. Let's see. Okay, as suggested by Excel, we just got the first line easily. We don't really need to do some heavy lifting to do. And then I would just want to get these numbers, 200. How would I do that? I could just use Presto split, and we split it with the thing, space. And then we set this inside string array. So first line. So instead of printing the whole line, I can just like this. See? So why it's one? Because you know the format of an HTTP response is always the HTTP version, status code, and then the text or the explanation of that status code. So if we want to take just the status code, we just need to take the second element from the first line after it was split using with a space. So in here, let's say we have HTTP 1.1200. Okay, so this is the return value from this line. And then after this line, we will have three elements. The first one is HTTP 1.1, and then the second one is 200, and then the third element is okay. And then in here, because I just want to print the status code, I just type it like this. Okay. What if you want to read the rest of the HTTP headers? Well, you just need to repeat calling this function, right? Or there's another alternative because this is a deprecated function. You can also, there are two options. You can read the whole message and then parse the message using some string functions, or you can read small chunks of the message one is time and then see if it contains the information that you need. The second one is a bit harder, but the benefit is you don't have to read the whole message if you just want to read the first few lines. While the first approach, it is easier from the programmer point of view because you just read the whole message and then split it just like you deal with a file. But the disadvantage is you have to read the whole message. If the content of the file is quite big, or if the content of the HTTP response is quite big, you will need to have a big memory to store all of them. Okay, any questions about this? I believe I don't have to teach you how to parse the information because it's mainly string operation. You can split, you can use split, you can use regex, or you can use find. I think there's something like char add or substring content equals contains. There are lots of functions here that you can use to parse the information. Okay. Are you sure you don't have any questions? Well, okay. If there's no more questions, there are some. These are some further readings. If you want to read more about HTTP, you can always look at the official documentation. That is really long, or you can use a simple one from this website. This is a good website that explains various HTTP headers for you. If you want to have a look at the short explanation, go to this website. Okay. Maybe that's it for today. Oh yeah, sorry. That's not the end of the lecture. So as promised, I'm giving you an assignment. So the assignment's a bit different from what I explained before. This time I need the whole class to create a simple web browser. So we will not be developing an email client. So it's just a simple web browser. And these are the requirements. I'm going to put the details on Classroom later. So I need you to develop a simple web browser. It doesn't have to be GUI based. You can use a text-based application as long as it satisfies these requirements. So I need you to open a web page. So the simple web browser needs to be able to open a web page if they the text. I don't need the header inside the response. Okay, so it's just like using the usual browser. You don't see the HTTP headers unless you need to do something with your browser. So in here, I just want to see the text. And then this might be the most difficult part. After showing the text, I need your web browser to show a list of clickable links. So I need you to find any links, any a tag and anchor tag in the HTML file. And then you need to find the link that you need, or the URL that you need to click or that you need to go. So for example, here, let me see with Monta. So this is an example. I'm gonna see not this one. Okay. So you see some links here, like this one, A, and then href, http monta.exe, and so on. So I need you to extract this message, the link and the text, and present it in a list. Jadi ditampilkan nama linknya apa dan URL linknya apa, bersebelahan gitu ya. Misalkan topik TA, itu link yang harus dibuka ini, pencarian TA yang harus dibuka ini. Jadi informasi-informasi yang lain yang tidak perlu seperti li, kemudian UL dan kawan-kawannya, kode HTML yang lain, itu tidak perlu. Kemudian dia bisa download sebuah file. So your web browser needs to be able to download a file regardless of its size, as long as you have enough space in your hard drive. And then this is a bonus requirement. If you can download a file in parallel, I'll give you a bonus. So it's it acts like you know download manager, and it can also follow redirections. So if there's any refresh header or any location header, you need to follow the URL so that you can open the actual file, just like the normal web browser does. And then if there's any error message, I want to see the proper error message. So I don't want to see the I don't want to see the what's called. I don't want to see the raw message. So I want to see that, okay, if it's 404, what does it mean? If I see 200, sorry, not 200, maybe like 403, what does it mean? And then the web browser needs to be able to open a web page that is protected by HTTP basic authentication. And then all code again must be uploaded to GitHub, GitLab, or Bitbucket. I will ask you to submit. I will ask each group to submit the URL of their repository, and then what else? Oh yeah, if you need some information about all of this, the suggestion that I can say is by using your web browser. That's actually the quickest way to do it. So for example, here, okay, I want to follow redirections. So I'm gonna find a website that has some redirection. Monta is the best example. And then I will check it with, can you see the browser, by the way?
Yes, sir.
Okay, so I'm using Chrome here. So if you just open the web developer and then click on the network tab and then click check the preserve log. So I'm gonna use here Monta because I know that Monta has some redirections. So I can see what requests are made by the browser. So for example, this one, okay, I know that when my browser first tried to access monta.efs as a ID, the request header looks like this. I can just copy some stuff from here. And then I can see what the response header would look like. So I know what to expect. And then because we know that it's a redirection, I can see the next request, what kind of request the browser makes, and then what kind of response the server gave to the browser. So that's how you learn how to do it. Oh, and that's one thing that I forgot to put in such a requirement. The website needs to be able to log in to a system. So for example, like Monta, you can send your username and password and then log in to the system. Okay. You can have a look at how cookies work if you forgot about it. Otherwise, well, Stack Overflow is your friend. Okay, any question about the assignment?
I wanna ask.
Yeah.
We don't need UI, right, sir?
No.
Just like console application.
Yes, text-based
Okay.
application is fine.
Thank you, sir. And one more, sir. How about the group?
Oh, you can decide it yourself. Just pick your own teammates. It's a group of 2, by the way.
Photo. Okay.
It's a group of 2. I don't know how many people we have. I think it's 28. So if it's 28, should be an even number. So everyone can have a group of 2.
What about the deadline, sir?
It's next week.
Next week, Wednesday.
Yes.
Ah,
You will demonstrate your work next week.
okay. Thank you, sir.
Oh yeah, and as for the code, I don't share the code. But you can capture the code snippet here. Well, most of them are actually already in the slide, but if you want to have a look at this one, feel free to capture it, because I encourage you to type, even though you just copy it from my code. At least I need you to type the code on your own. Anything else?
I want to talk about download of file regardless its size and download of file in parallel. Is it we go into an URI and then we download a file that is available at that URI, or?
Yes. Yes.
Oh, okay.
So you just need to input the URI of the file, and then it will automatically download the file if it's not an HTML. If it's an HTML, you need to show it. Okay. Anything else?
And then could you define about HTTP perspective HTTP error message? Is it
Oke.
like
Ini contohnya kayak gini. Misalkan kita dapat error 404 ya. Misalkan kita dapat error 404, itu jangan ditampilkan pesan error yang langsung dari ini ya, dari server. Misalkan ketika dapat 0404, kalian tampilkan file tidak ketemu, atau intinya cukup jelas.
okay, sir?
Okay.
I think it is well explained.
Okay, anyone else? Well, otherwise this is the actual end of meeting. Just gonna stop sharing. And if you have any more questions, you can also email me or chat me on Teams. Okay, I think that's enough. I'll see you again next week. Good luck with the assignment. Okay, I'm just